So here is the Excel sheet which I have made to prepare a stat file for any particular kind of SED, and this file helps structural engineer to make any SED span up to 50 meter, and it will create everything, and it made a ready-made stat file in which structural engineer only have to do analysis button to click. So this is the input sheet for this Excel, where users have to put inputs mentioned in these yellow color boxes, and all these inputs are as per Indian wind load, and which is 875 part 3, and like weight of seat roofing, weight of fixers, weight of bracings, basic wind speed, which are ranging from 33 to 55. Then there are provision for some inputs, like as here mentioned, that part 2 gives the provision to decrease live load up to two-thirds when slope is higher than the 10-degree. So there are some practice that some engineers use this and some are not and design it conservatively. Then this risk coefficient, then terrain category, which are 1 to 4, then building class, which is 1 8 BC, like 20 meter, 20 to 50 meter, greater than 50 meter, topography factor. This set also includes cyclonic effect, which is mentioned in the latest code of this 875, and then wind directional factors. And there is also, I put the provision where someone just keep this using considering effect of KD, K, and KC as per latest code. Then this inputs, it's for CPI, where depending upon the opening size of the truss, and then these are the geometry inputs. W, which W stand for the truss span, like like this. So this is W, truss span. L, length of side, and small height of view. Then H1 is the ridge height, and H is the total height. So if this should be input, if I keep right now as a 15, and this should be like, for an example, 40 meter, then height, it is, I put much higher. Let's go for 10 meter, then bottom level as a 0, and then X and Y. So this X and Y creates calculation for this internal frame. So let me select, if this is a 15, let's go for a 5, no, 40. So let's go for a, say, 5 meter, so 8 spans. So X is, say, uh, 5 meter, yeah. So now here this set works for the equal span, so like both span A and B are same. So I keep it the equal span. Now here I put one cross connection with the purlin design, where I can design my purlin from state from here, like say here MC125 pass, and this is the purlin member for the site. So say it's not pass because of this gravity force. Yeah, so now loading of these purlins R has been included in the total file. So this, so if someone's not don't want to make a stat file and he just want reactions forces. So this is the sheet from where he can find out loads which are calculated as per IS codes, and one can directly apply on their stat file. So this is all about. So this is I have put as a different, like this is the UDL and this is the point load, because point load give more deflection. Many structural engineers are used to put point load at the location of purlins. Then this is the for vertical horizontal force on the column, and K2 factor collections, and this is like stat file. So whatever the stat file this set will make, this is the some background working. So uh, so one can go directly from here like whole stat file. So once has to select internal frame or external frame. So I go for the internal frame. I just click here, create stat file. So there is a macro behind, and it make a stat file. Stat file is created on your folder. Now click on the run stat file. Say okay, run stat file. Yeah, it's just a notice about potential blah blah blah. But yeah, so yes and okay. So you can see the state file is created. Let's check. So if you remember, I put the span as a 15 meter, and you can find this stat is made with the 15-meter span. This inclination I have fixed as a 12 degree, so this height should be calculated accordingly. This should be the like point 0.3. So because like in the fabrications, this top runner and this one has some gap between, so that's why I create this point 0.3 gap. Now if we go one by one, you can see um, these are the sections which is already fitted, but one can change according to their assumptions or the material availability. And now when I go over the um, support, one can see there is a pin support, and on other side is a roller support. Now go for a loading. One can see seismic parameters has been given here, so one can change according to the zone of earthquake. Now these are the primary load cases and these are the combinations. So these are the combination according to IS code. So if we go one by one for the loading, so one can see sulfate, this is the purlin load, this is the dead load like seating load, and this is the live load, and this is the wind load in x direction, internal pressure, this is the z wind. So you can see all the wind forces according to IS code has been applied, calculated, and everything. Just one need to save like this and just analysis. So done, analysis done. If I go for the post processing, apply OK, and if I go for the reactions, I got the reactions, and if I say it's a pass or not, apply OK. So this is how entire design thing has been done. So design parameter is also defined here. One can modify the design parameters according to their office practices or their engineering practices. So this is the Excel. So if someone's want to make a stat file for this truss, it at least take a half an hour to make a geometry, finding opening the code, finding out all the forces, and complete this analysis. Using this Excel, one can make any kind any stat file of any span ranging from 1 meter to 50 meter within 5 minutes. So here is my work. Suggest me any more things I can do in this Excel file. Thank you for watching.